Hi, good morning, students. Today's your topic is to state the composition of air and fractional distillation of air. So first we'll see the percentage of each gases which is present in air. So mainly air contains 78% of nitrogen and 21% of oxygen and 1% other gases. Other gases contains carbon dioxide, argon, neon, helium, that is some of the noble gases. Now we will see the pie chart for the composition of air. So when you see the pie chart, the blue part represents 78% of nitrogen and the green part represents 21% of oxygen. Now we are going to the new topic, that is fractional distillation of air. So fractional distillation of air is similar to fractional distillation of crude oil. So fractional distillation, it is based on the difference in boiling point. So how we did in crude oil, we boiled the crude oil. So the gases, the oil changes to gases. According to their boiling point, they are collected at different layers and they will condense there and can be collected as liquid in liquid state at different layers. The same process we are going to do for fractional distillation of air. But here, first we have to convert air into liquefied air. So to convert air into liquefied air, first we'll compress it, then we'll allow it to expand. So this process goes on. Okay, compression, then expansion, compression, then expansion. So by minus 200 degrees, the air is converted to liquid air. So in this liquid, some of the gases will not turn to liquid, so we can remove it. uh, the process for removing, they are separated from each other by absorption on charcoal. This you can see in the video. Then the next step is the liquid air is then passed through the fractionating column, fractional distillation column. Okay, so there what happens in fractional distillation column, the liquid air then boils up. That means it changes to gases, and according to the boiling point, they are collected at different layers. Here we want only oxygen and nitrogen. So when you see the boiling point of oxygen and nitrogen, what you can understand, which one will boil first, which one will be collected first. Okay, so when you see this, the nitrogen gas will boil off first. Since they are negative values, nitrogen gas will boil off first. Okay, and it will be collected. You can see here a fractional distillation column for air I have taken like this, and here you can see at minus 196 degrees what happens, we can collect the nitrogen gas, gaseous nitrogen out, and at minus 183 degrees liquid oxygen is going out. Okay, so you can see the picture in page number 208. Either you can follow that flow chart or you can draw this diagram in your notebook. So I prefer you to draw this diagram and study from the textbook also. So mainly you have to study the boiling points of nitrogen and oxygen. So you know the uses of nitrogen and oxygen. Why? What is the purpose of separating these gases? So you know nitrogen. What is the use of this? It is highly unreactive. Nitrogen, you know, N triple bond N. It's highly unreactive. So it is used in food packaging. Okay, and oxygen, you know, one important use of oxygen is it is used in the conversion of impure iron from the blast furnace into steel. And one more use, you all will know, oxygen for artificial breathing. All hospitals needs oxygen cylinders. Hope you understood this. Please try to answer all the questions here. Describe with the help of a diagram the separation of oxygen and nitrogen by fractional distillation of air. In this, please, you have to draw the diagram which is given in the blog. And your next question is list the process that takes place during fractional distillation of air. This already we have done in fractional distillation of crude oil. These topics you can find in page number 208 and 209 in your notebook. So please complete all the answers in your notebook with today's date. Hope you understood the topic. If there is any doubts, you can clear it through mail or WhatsApp group. Thanks.